Okay, so I'm just remembering now to start recording. Let's see what we get. Common tangents are congruent when one endpoint is shared and the other endpoint of each is tangent to the same circle. Let's see, I have no idea what that means. Don't worry, I'll explain it to you. I didn't give myself a lot of room, but, so let's talk about it down here. Say I have, huh?
Little thing on the top.
Cool. So we have Andrew's freaked out on.
No, I just restarted recording it right now. So we don't. Yeah, I'm sure we'll get another one.
It's okay, I'm freaking out because I just realized I don't have my calculator for my science test.
You never have your calculator.
That fruit fly might come back, who knows?
Yeah, but this one like actually needs a calculator.
It does.
All right, so here's what this theorem is telling us. Say I have a circle and I have two lines that are tangent to the same circle. Okay, so that might look something like this. If I have a tangent coming off there and a tangent coming off here. So, in this scenario, when the two tangents, right, if they meet at a common point, so one endpoint is shared, and then the other endpoint of each one is tangent to my circle. So if I have that scenario, here's what I know about those two tangent lines. They're congruent to each other. I don't know, for whatever reason, but I always think of this as eating a sushi roll with chopsticks. Right? You know when you have a sushi roll and you pick it up with the chopsticks, doesn't it look right? Where the chopsticks meet those, yeah, okay. That's what I think of, but you do you.
But right now, I think I would like it to be a Santa hat.
Oh, that'd be cute too. I never thought of it that way.
Or an ice cream cone.
Or a wizard hat.
Mmm. However you like, those two sides are going to be congruent.
Oh.
Okay, so the next one says, if a line is perpendicular to the radius of a circle at the point of tangency, then, so here's what, let me draw you this picture first. Here's what we know. If I have this, if I have a radius or a diameter, it doesn't always have to be a radius, and I know that that's a right angle, that just tells me that this line here has to be tangent to the circle. That's all it's saying. So if a line is perpendicular to the radius or diameter of a circle at the point of tangency, then the line is tangent to the circle. That one's kind of self-explanatory, I think. Oh yeah, sorry. And then we have two different types of common tangents. You have a common internal and a common external. So let's think about what this is even saying. If I have common tangent lines, so if I have two circles, how could I have a common tangent line? Yeah, it's just a line that's going to be tangent to two circles. So imagine the floor and two bowling balls on the floor, right? The floor would be a common tangent to those two circles, two bowling balls, right? So that would actually be a common external tangent, that example I just gave you. So if I had two bowling balls, and the bowling balls don't even have to be the same size. Say I had a bowling ball and like a golf ball, sure, or a marble or something, and then they were both just sitting on the floor. As long as that line is tangent to both circles, we would call that, in this scenario, a common external tangent. A common internal tangent is when the tangent line is going to pass in between the two circles. So they can be the same size, they can be different sizes, it really doesn't matter. So say I had something like this, and my tangent line went like this. Okay, so this is a common internal tangent where the tangent line passes inside, in between the two circles. So if you want to write it in words, tangent line passes in between circles. And then our external tangent, the tangent line stays outside the two circles. Well, you get what I'm saying. It doesn't cross in between the two circles. So, does that make sense? Okay, so common tangent line just has to be tangent to two or more circles. Internal crosses in between the two. External does not cross in between the two. Then I can have something called tangent circles. That's when I have two circles that share a point between the two of them. So they look like this. Tangent circles. Usually you have a bigger one and then like a littler one, and they're tangent to each other. It could be like that, or you could have it like this too. By the end of this chapter, it's funny because you get really good at drawing circles. So always on the first day, they're like so lumpy, but by the end, usually you get really good because you've drawn so many of them. And we do refer to these usually, these ones would be internally tangent. Because one's inside of the other. And then we have externally tangent. And then just to make this video complete, I'm just going to go back and just reread this one theorem because I skipped over it. So if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So what that's saying is if I have a line that I know is tangent to my circle, if I draw a radius to that point, or a diameter, it doesn't matter, you know that that's going to be a right angle. Okay? That's all that's saying.